Welcome back to another video, and in this video it's going to be the last time that we really use Visual Studio, because we're going to transition over to using the Arduino IDE and Arduino boards for hardware. And I think it's fine to just strictly teach C++ in a course, but for an electrical engineer you probably are concerned somewhat about the hardware that you're interfacing with, and having something in reality that you can write code to do something. Now, nicely enough, the Arduino platform uses a variant of C++, so all of the things here should translate fairly okay to Arduinos. But to end the C++ Visual Studio part at a cliffhanger, we're going to talk about really one of the most important things in C++, and that's going to be classes and objects. Now, while this is the bread and butter for C++, we kind of had to go through everything to get to this point to understand it. And after we go through all of this, it might seem very abstract or obscure, and maybe you ask the questions of why we do things this way. But I think having a video that leaves more questions than answers is sometimes good, especially in writing code. So C++ is something that we call an object-oriented programming language, often given by OOP. And in this OOP, we use classes and objects. Now, affiliated with those, we have things like attributes and methods. So a class is a user-defined data type, and it groups info together. And a class has attributes. Now, attributes are variables that belong to the class. And then an object is going to be an instance of the class. So maybe to make this more understandable, let's look at an example. And let's say you have a garage, and inside that garage, you have the information of the car and the model year. And what we could actually do is call this garage a class. So we'd define class here. We'd have our name of garage, and then we'd have some squiggly brackets. We'd have this line public, which could be public, private, or protected. We'll get into that a little bit later. But then we would have a string defined as our car name, and then we would have an integer as the model year of that car. So if we look into what these few lines of code are doing, when we have class, this creates a class. And in the next line, when we had public, well, inside of this class, we're going to have things called members. Now, these members can be attributes or methods, and methods would relate to functions. But by having this line of public, it says that these members can be accessed outside of the class. Now, maybe we don't want that to happen. Maybe we want to use the private or protected feature. And then these members, that would be the string and integer, and those would be our attributes. Now, similar to functions, classes get defined outside of the main, but we can use them inside. And we can define something called an instance, and that's going to be the occurrence of a class. So let's say we had multiple garages at separate houses, and inside the main, you would access your house 1 and house 2. And then we could define the attributes, simply using this house 1 dot and then car name. So this convention is a little bit familiar, and then whatever the content is, we would put in there. And then notice here, we would just be matching this variable here, and we could do the same for the model year. So if we go into Visual Studio, we can just have a basic code. So the first thing that we defined is this class, so we called it garage, and we're just going to set it to public. So we have our attributes here, our car name and model year. And then here we have some methods, so we define this function, just called it function, and it's going to output car name and model year. So here's our class. We have both attributes and methods. And then if we scroll down to the main, so in line 16, we create an object of garage. We're just going to call that house 1. And then for that first house, what we're going to do is simply define the car name and model year. So here we just have car name 1, pretty generic, and then model year of 2020. Then we use that function simply by tagging it on to house 1. And then we're going to use our common sleep function, and then we do the same for the second house. So if we run this code, you can see here we get car name 1, and then the year, and then car name 2, and then the respected year. And maybe you're asking why even structure the code like this, and there's a few good reasons. So the first thing, that's going to be something called encapsulation. So with these classes, we can bundle attributes and methods together under one umbrella, but we also have this privacy of attributes. So in our example, we used public, but we could also use private and protected. And that allows us to hide these attributes if we need to. The next thing would be polymorphism, and this allows us to work with many forms of objects. We have inheritance, so we can have classes that inherit properties from other classes. And then there's a few more things. We can have modularity, we can have abstraction. Now there could be a whole series of videos simply on the object-oriented programming of C++. But again, we probably want to have some hardware in our hands we can interact with as electrical engineers. So this is where we transition to Arduinos. So if you go onto the Arduino website and you just go into the hardware, what you can see as you scroll is that there are a bunch of different families of hardware. And what all of these boards do is they have a microcontroller on them, and the microcontroller is able to exert some code. But the question is, where do you write that code? Well, for that you have to use something called the Arduino IDE. So it allows us to write some code, compile it, and then feed it onto the hardware. Now for all the future videos, I am using this legacy IDE. Personally, I like it better. And then going back to the hardware, we're going to use a few boards for different projects. So we're going to have kind of a entry-level project, a medium project, and then a pretty hard project. So if we're looking at our inventory, we have several Arduino Nano Everys, which are pretty basic boards. We have a Mega, so an Arduino Mega 2560. But we can go one step further, and we actually have an Arduino Giga R1 with Wi-Fi capability, and that actually pairs to the Giga display shield so you can have a touchscreen. So if we scroll up and simply look at the Nano Every, now depending what board you can actually get the pins that you can connect to a breadboard. But then to actually see what's inside of this Nano Every, we can scroll down to the tech specs. You can see here we have some memory, some clock, some PWM pins which are going to be important, and then we have a few pins that are dedicated to communication, and we'll see that later on. We have some analog pins, both input and output. There's actually a built-in LED, and then we have the length, width, and weight of the device. So if you need more, you can actually look at the datasheet, and what's great about Arduino is they also provide the schematics. But if we look at the datasheet and we scroll down a few pages, you can see on page 7, we have what each pin is designated to. And then if we keep scrolling down, you actually get a list of which pin, the function of that pin, the type of pin, and then the description of what it can do. And then if we actually open up that Arduino IDE and we open up an example code. So this is just an example code that's going to turn off and on an LED. So it's going to make it blink. What you're always going to need is this void setup and void loop. And this void setup, it will run once you press reset or power the board. Now we need this void setup so we can set up certain things that need to be set initially. So you can think of this as designating pins, certain responsibilities. And then you have this void loop, so you can think of this kind of as the main, so it runs automatically and it loops forever and ever and ever. But this is now the interface that we're going to use instead of Visual Studio. And in the next video, we're going to describe a project that we want to do with an Arduino, and then we're going to show how we can actually accomplish that. If you learn anything new, please like, comment, share, subscribe. It helps the YouTube algorithm, and we'll see you in the next video.